2 Boeing 747s, 1 runway, Sikfog. 583 people would die in the next 60 seconds. Neither aircraft had left the ground. The 27th of March, 1977. Tenerife. It is still the deadliest accident in aviation history, and it happened because of a single word spoken on a radio that meant two different things to two different crews. These are the 5 deadliest accidents in the history of commercial flight, ranked by lives lost and by the rule each one left behind. Before we begin, one thing needs to be said plainly because it changes the list. This is a ranking of accidents. It is not a ranking of the deadliest days in the air. 2 events killed more people than anything you are about to see, and neither of them appears here. The attacks of September 11th were not accidents. Air India Flight 182, which went down off the coast of Ireland in 1985 with 329 people aboard, was destroyed by a bomb. Those are security failures, and their lessons belong to a different story. What follows are the 5 worst accidents in the history of commercial flight. Failures of metal, of procedure, of language, and of judgment. And each one of them ended with a rule. Every one of these 5 accidents changed something concrete about how aircraft are built, repaired, flown, or spoken to. That is the thread running through this entire video. Not the loss. What the loss bought. We will count down from 5 to 1. And the further down we go, the more you will notice something uncomfortable. In almost every case, somebody already knew. Number 5. The 19th of August, 1980. Riyadh, Saudi Arabia. 301 people. Saudia Flight 163 was a Lockheed L-1011 TriStar, a wide-body trijet, one of the most advanced airliners of its generation. It lifted off from Riyadh in the evening, bound for Jeddah, with 301 people on board. 7 minutes after takeoff, warning lights indicated smoke in the aft cargo compartment. The crew turned back. And here is where this accident separates itself from every other accident on this list. The airplane made it. Flight 163 returned to Riyadh and landed successfully. It rolled out, turned off the runway. It came to a stop on the taxiway, intact, upright, with 301 people alive inside it. And then nothing happened. The engines were not shut down for another 3 minutes. No evacuation was ordered. The crew had reported that they were ready to evacuate, but the order was never given and the doors were never opened from the inside. Emergency crews reached the aircraft, but the doors were designed to be operated from within, and the cabin was still pressurized, which meant the doors physically would not move. 26 minutes after the aircraft came to a stop, ground personnel forced the right second door open. By then, the fire that had begun in the cargo hold had burned upward through the cabin floor. The autopsies are what make this accident so difficult to read about decades later. Every single person on board died of smoke inhalation. Not one of them died of burns. They were gone before the door opened, inside an aircraft that had landed safely, sitting still on the ground, at their own destination airport. The investigation could not determine what started the fire. The origin was placed in the aft C3 cargo compartment, and an early theory about a passenger's portable stove was examined and found unsupported by evidence. But the cause of the fire turned out to matter far less than what happened after it. There is a design question underneath this accident that took the industry years to answer honestly. Cargo compartments on airliners are classified by how a fire in them is expected to be handled. Some classes assume a crew member can reach the fire. Others assume the compartment is sealed tightly enough that a fire will consume the available oxygen and smother itself. That second assumption depends entirely on the compartment staying sealed and on the contents not supplying their own oxygen. A fire that burns through the ceiling of the compartment is no longer sealed. It is being fed by the cabin above it. And the first sign the people in that cabin have is smoke coming up through the floor. The rule this accident left behind is not one rule but a family of them. Fire detection and suppression standards for cargo compartments were tightened, and the classes that relied on a fire smothering itself were progressively pushed out of passenger aircraft in favor of compartments with active detection and suppression. Flammability requirements for cabin materials were rewritten. And most importantly, the decision to evacuate was moved to the very front of crew training and stripped of hesitation. A modern crew is trained that an evacuation decision made too early costs money, and an evacuation decision made too late costs everything. Flight 163 is why that sentence exists. It is also why cabin crew today are authorized to begin an evacuation on their own judgment if the flight deck has gone silent. The authority to open those doors no longer sits in one place. Number 4. The 3rd of March, 1974. The forest of Ermenonville, north of Paris. 346 people. Turkish Airlines Flight 981 was a McDonnell Douglas DC-10, climbing out of Orly bound for London. 335 passengers, 11 crew. Many of the passengers were traveling because a strike had grounded another airline, and this flight was the one with seats left. 12 minutes after takeoff, at around 12,000 feet, the rear cargo door separated from the aircraft. What followed took 77 seconds. When the door left, the pressure in the cargo hold dropped instantly while the cabin above it was still pressurized. The cabin floor was not designed to survive that difference. Collapsed downward. And running through that floor, as they did on every DC-10, were the control cables to the tail. The crew still had engines. They had almost nothing else. 77 seconds after the door failed, the aircraft struck the forest at close to 500 miles an hour. There were no survivors. At the time, it was the deadliest accident in aviation history. Now the part that makes this the hardest story in this video to tell calmly. The failure mode was not a surprise. It was not a freak event. It had been identified in 1969, before the DC-10 entered service. It was reproduced deliberately in ground testing in 1970, where engineers watched the cargo door fail and the floor collapse exactly as it later would over France. A subcontractor's engineer wrote an internal memorandum warning that this door would eventually open in flight and would probably result in the loss of an aircraft. That document is known today as the Applegate Memorandum. And then in 1972 it actually happened. American Airlines Flight 96 lost the same cargo door over Windsor, Ontario. The floor partially collapsed. The crew, through a combination of skill and luck in how the damage fell, landed the aircraft. Everyone survived. That was a free warning delivered 2 years early, with no cost in lives. No airworthiness directive was issued. The fix was handled through an arrangement between the manufacturer and the regulator rather than through a mandatory order. Service bulletins went out. The aircraft that crashed near Paris had a latching mechanism whose locking pins had been filed down, which allowed the handle to be forced closed while the latches were not actually engaged. The rule this accident left behind was written in 2 parts. The cargo door latching system was completely redesigned so that a door cannot indicate locked unless it is locked. And separately, and far more importantly for every aircraft you have ever flown on, floor venting became a requirement. Modern airliner cabin floors have vents so that a sudden pressure difference equalizes through the vents instead of collapsing the floor onto the flight controls. There is a second rule, and it is not written in any regulation. It is the reason the phrase known risk carries the weight it does in aviation engineering. After 1974, a documented, reproduced, predicted failure mode could no longer be managed quietly. Number 3. The 12th of November, 1996. Charkhi Dadri, in the Indian state of Haryana. 349 people. Saudia Flight 763, a Boeing 747, had just left Delhi and was climbing. Kazakhstan Airlines Flight 1907, an Aviation IL-76 cargo aircraft, was inbound to Delhi and descending. They were using the same corridor because at that time Delhi had one, shared between arrivals and departures. The controller cleared the Saudia flight to climb to 14,000 feet. He cleared the Kazakh flight to descend to 15,000. 1,000 feet of vertical separation, which is the standard and which is enough. The Kazakh aircraft did not stop at 15,000. It continued down through its cleared altitude into the block of air the Saudia 747 was climbing into. The two aircraft met head-on. Investigators focused on the cockpit of the IL-76. The crew's English was weak. They did not communicate with air traffic control directly. A dedicated radio operator relayed instructions to the pilots. When the controller mentioned the Saudia aircraft at 14,000 feet, it is considered likely that this was heard, relayed, or understood as their own instruction. There was no collision avoidance equipment on board either aircraft. There was no secondary surveillance radar at Delhi providing the controller with automatic altitude readouts. The controller had no independent way to see that one of his aircraft was 300 meters below where he had put it, until it was too late for anyone to do anything. It is worth pausing on how thin the margin was. 1,000 feet of vertical separation between two aircraft closing head-on is, in time, a matter of seconds. Neither crew was doing anything reckless. The Saudia crew were exactly where they had been told to be. The controller had issued a correct and standard clearance. Every element of the system worked except one, and the system had no way of noticing that the one had failed. India's response set a global precedent. The country mandated collision avoidance equipment for every aircraft operating in Indian airspace, the first mandate of its kind anywhere. That system, which we now call TCAS, does not ask air traffic control for permission and does not depend on anyone's English. Two aircraft carrying it negotiate directly with each other, machine to machine, and instruct their crews to climb or descend in opposite directions. It is one of the few safety systems in aviation that works entirely without words. It works by having each aircraft interrogate the transponders around it and build its own picture of who is nearby and where they are going. If two aircraft are projected to come too close, both systems talk to each other, agree which one will go up and which will go down, and then tell their crews. The instruction is not a suggestion. Crews are trained to follow a resolution advisory immediately, and to follow it even if air traffic control is telling them something different at that moment, because the two aircraft have already agreed with each other, and the controller has not been part of that conversation. Delhi's shared corridor was separated into distinct inbound and outbound routes, and the amount of airspace under exclusive military control was reduced. Secondary radar was installed, and the question of language proficiency in the cockpit, which had been an uncomfortable subject for years, became something the industry could no longer avoid. Formal English language proficiency standards for pilots and controllers on international routes followed, with required testing and periodic reassessment. Number 2. The 12th of August, 1985. Mount Takamagara, Japan. 520 people. Japan Airlines Flight 123 was a Boeing 747, registration Juliet Alpha 8119, on a short domestic hop from Tokyo to Osaka. It was the height of the Obon holiday season and the aircraft was nearly full, 524 people on a flight scheduled to last under an hour. 12 minutes after departure, at 24,000 feet, the aft pressure bulkhead failed. To understand what that means, you have to know what that bulkhead does. It is the dome of metal that seals the back of the pressurized cabin. Behind it is the tail, which is not pressurized. When it ruptured, the cabin's air rushed backwards into the tail section all at once. It tore off most of the vertical stabilizer, and it severed all 4 hydraulic systems. The 747 has 4 independent hydraulic systems specifically so that no single event can take all of them. This event took all of them. Within seconds, the crew had no rudder, no elevators, no ailerons, no spoilers, and no functioning landing gear controls. They had 4 engines and a control yoke connected to nothing. They flew for 32 more minutes. Using engine thrust alone, pushing power up on one side to turn, pulling it back to descend, the crew kept a crippled 747 in the air over central Japan for half an hour. What they were fighting has a name. An aircraft without working elevators still wants to hold a speed, and when it is disturbed it trades altitude for speed and back again in a slow cycle, climbing and descending in long waves that can take a minute or more each. It is called a phugoid, and adding thrust to climb makes the next wave larger, not smaller. There is no intuitive way to stop it. Every instinct a pilot has trained for makes it worse. They fought it the entire time. At the end of those 32 minutes, the aircraft struck a ridge in the mountains of Gunma Prefecture. 4 years later, the crew of United Airlines Flight 232 lost all hydraulics in a DC-10 over Iowa, in a very similar situation, and got their aircraft to a runway at Sioux City using the same thrust-only technique. 185 of the 296 people on board survived. That crew had trained for it, informally, on their own initiative, partly because of what had happened in Japan. For people survived. All 4 were women seated toward the rear of the cabin. The cause was found in a repair carried out 7 years earlier. In 1978, this same aircraft had struck its tail on the runway during a landing at Osaka. The aft pressure bulkhead was damaged and had to be repaired, and the correct repair called for a single continuous splice plate secured with 3 rows of rivets. The technicians used 2 separate plates instead of 1. On one of the plates, only a single row of rivets did any real work. Investigators calculated that this reduced the repaired joint's resistance to fatigue cracking to roughly 70% of what a correct repair would have given. Then the aircraft went back into service and was pressurized and depressurized, once per flight, 12,318 more times. The crack grew a little with each cycle, invisible from the cabin, until the 12th of August 1985, when it grew all the way. This remains the deadliest accident involving a single aircraft in the history of aviation. The rule it left behind concerns how repairs are certified and inspected. A structural repair to a pressure vessel is no longer a job that ends when the aircraft flies again. Documentation, independent verification, and long-term inspection of repaired structure were all tightened. Japan Airlines went further than regulation required and built a permanent safety promotion center at Haneda, where wreckage from this aircraft is displayed, and where every new employee of the airline is taken. Number 1. The 27th of March, 1977. Los Rodeos Airport, Tenerife. 583 people. Neither of these aircraft was supposed to be in Tenerife that day. Both were bound for Gran Canaria, and both had been diverted after a bomb was detonated at the terminal there. Los Rodeos was a smaller airport, and it filled with diverted wide-bodies until aircraft were parked on the taxiway. That detail matters because with the taxiway occupied, an aircraft that needed to reach the start of the runway had to taxi along the runway itself and turn around at the end. That procedure is called backtracking, and on that afternoon both the KLM and the Pan Am 747 had to do it. Then the fog came in. Visibility collapsed. The tower could not see the runway. Neither aircraft could see the other. Los Rodeos had no ground radar. There is one more pressure worth naming, because it explains the urgency without excusing anything. Dutch duty time rules had recently been tightened, and the penalties for exceeding them had become personal and legal rather than a matter of company discretion. The KLM crew were approaching a hard limit. If they did not depart soon, the aircraft and its passengers would be stuck on Tenerife overnight. The captain also chose to take on a full load of fuel while waiting, a decision that added time on the ground and added weight that would matter very much in the last few seconds. The KLM aircraft backtracked, reached the end, and turned to face down the runway. The Pan Am aircraft was still on that runway behind it, looking for a taxiway exit it could not clearly see in the fog. The KLM captain advanced the throttles. His first officer transmitted that they were, quote, at takeoff. The controller replied with the words okay, then stand by for takeoff, I will call you. At that moment the Pan Am crew also transmitted, saying they were still on the runway. The Pan Am transmission and the controller's transmission reached the KLM aircraft at the same instant. On a radio, two signals on one frequency do not arrive as two messages. They interfere. What the KLM crew heard was a squeal, and out of the whole exchange only the word OK survived intelligibly. The KLM flight engineer asked whether the Pan Am aircraft was clear of the runway. He was told that it was. The takeoff continued. The two aircraft became visible to each other with a few seconds remaining. The KLM captain pulled up hard enough to strike his tail on the runway. The Pan Am crew turned to leave the pavement. Neither maneuver could finish in the distance available. 583 people died. 61 survived, all of them from the Pan Am aircraft. Everyone aboard the KLM aircraft was killed. It remains the deadliest accident in the history of aviation, and both airplanes were on the ground. There was no mechanical failure. Both aircraft were serviceable. What failed was language, and the assumption that everyone in the exchange meant the same thing by the same words. So the industry changed the words. The single largest phraseology reform in aviation history came out of this accident, and you can hear it on any frequency today. The word takeoff is now spoken only in the actual clearance, cleared for takeoff, or in canceling it. At every other point in the conversation, crews and controllers say departure instead. An aircraft cannot casually announce it is at takeoff, because that phrase no longer exists. Acknowledgements change too. Roger and OK are no longer acceptable responses to a clearance. The key elements must be read back in full, so that the controller hears what the crew believes it was told. And a clearance issued to an aircraft already lined up on a runway must be prefixed with the words hold position. There is one more legacy, and it is the largest of all. The KLM captain was the airline's chief of flight training, one of the most senior and most respected pilots in the company. His flight engineer raised a doubt about the Pan Am aircraft and did not press it when he was answered. The industry looked at that dynamic and concluded that a cockpit which cannot be contradicted is a cockpit with one point of failure. The response is called crew resource management. It formalizes the idea that authority does not make a person correct, that a junior crew member is obligated to speak up, and that the captain is obligated to listen. It began as an idea after Tenerife and became mandatory training for airline pilots worldwide. It is now taught outside aviation entirely, in operating theaters, in power stations, in any room where seniority could stop somebody from saying something is wrong. 5 accidents. 1,899 people. Look at what actually caused them. One airplane was destroyed by a door that a company had already been warned about in writing. One was destroyed by a repair that was signed off and then forgotten for 12,000 flights. One was destroyed because 2 crews and a controller did not share enough language between them. One was destroyed by a fire that the aircraft survived and the evacuation did not. And the worst of them all was destroyed by a misunderstanding about a single word, between 2 crews who had done nothing wrong except assume they had been understood. Not one of these was an act of nature. Every single one was something a human being could have caught, and in several of them someone did catch it and it was not enough. That is the uncomfortable part. But here is the other part, and it is the reason this video exists. Every one of these accidents was answered. The door was redesigned. The floor was vented. The repair rules were rewritten. The collision avoidance system was mandated. The word takeoff was taken out of the language. The evacuation decision was moved to the front of training. And the cockpit stopped being a place where the captain could not be questioned. Commercial aviation in the 1970s killed roughly one passenger for every 200,000 flights. Today, on a modern airliner with a trained crew, you would have to fly every day for tens of thousands of years to expect to be in a fatal accident. That did not happen because flying got easier. It happened because the industry has an unusual and rather grim discipline. It treats every accident as a permanent instruction, writes the answer down, and makes it mandatory for everybody. These 5 accidents are the reason a great many people who are alive today are alive today. That does not make them less terrible. It is simply the only thing that could be salvaged. So the obvious question is whether any of that actually works. It is easy to list rules. Standard phraseology, mandatory readback, crew resource management, collision avoidance, cargo door design, repair certification, evacuation training. 7 paragraphs of consequence, bought at a price nobody would have chosen to pay. But a rule is only worth what it does on a bad night to a crew who are tired in weather with an aircraft that is not quite 100%. So for the second half of this video, we are going to do something different. We are going to take one ordinary accident, recent, obscure, and almost entirely forgotten, and watch that rulebook get used. It is not on any list of the deadliest anything. Nobody died. It made the local news for a day. And it is the single clearest demonstration you will find of what all those rules are actually for. The 3rd of May, 2019. Jacksonville, Florida. The 3rd of May, 2019. A Boeing 737-81Q, registration November 732 Mike Alpha, operating a charter flight for Miami Air International. The route was Guantanamo Bay, Cuba, to Jacksonville Naval Air Station in Florida. On board were 2 pilots, for flight attendants, 1 mechanic riding in the jump seat, and 136 passengers. Before departure, the crew reviewed the paperwork. Thunderstorms were forecast for their arrival time. The flight plan showed variable wind at 20 knots gusting to 30, thunderstorms, and rain. Orlando was listed as the alternate. There is one more item on that paperwork, and it matters more than anything else in this story. The number 1 thrust reverser, the left one, was not working. It had been deferred under the minimum equipment list, which is entirely legal. The aircraft was dispatched with one of its 2 reversers available. There is a second detail worth holding on to. This was the first time these 2 pilots had ever flown together. The captain was the pilot flying. He was also acting as a check airman, supervising the first officer, who was still completing his operating experience training. So the captain was doing 2 jobs at once, flying the airplane and assessing the man beside him. About 30 minutes before landing, the flight began deviating around weather. The captain later described it as, quote, nothing serious. Weather data for that period shows rain showers and thunderstorm growth over the airfield from 2110 onward. At 2122, the first officer checked in with approach control at 13,000 feet. The controller said to expect the area navigation approach to runway 28. 10 seconds later, the controller advised that there was moderate to heavy precipitation on the final approach to runway 28. The captain asked about the wind. It was from 350 at 4 knots. He then asked whether conditions looked better for runway 10, the opposite direction. The controller said runway 10 showed moderate to heavy precipitation beginning about 5 miles out. Read that again. Both approaches had moderate to heavy precipitation. The crew were choosing between 2 bad options, and the weather was moving. At 21:25 the controller offered them the choice again. The captain replied, quote, "Whichever looks better, and then when I get closer I check how it is." At 21:30, the controller advised that the precipitation was moving east and asked whether they wanted to change to runway 10. The captain said, quote, "Yeah, go ahead, let's do it." They had now switched runways twice in 8 minutes, in the dark, in weather, with a first officer who had never flown with this captain before and was still in training. At 21:39:38, the final controller took over and advised that the wheels should be down. Landing gear extension was recorded 10 seconds later. The flight was cleared to land. And then, at 21:40:15, the controller told them something that should have ended the approach. He advised the crew that they were, quote, "well above the 3-degree glide path." 10 seconds later, the precision approach path indicator, the row of lights beside the runway that tells a pilot whether the airplane is high or low, would have shown 4 white lights. For white means the airplane is above 3.5 degrees. It is the most unambiguous signal in visual aviation. You are too high. At that moment the aircraft was 3.5 nautical miles out, descending through 1,390 feet, at 158 knots indicated, descending at 1,062 feet per minute, with a 7-knot tailwind pushing its ground speed to 174. The target approach speed for that aircraft at that weight was 153 knots. At 21:40:25 the autopilot disconnected. The captain was now hand-flying. The descent rate increased from 1,100 to 1,400 feet per minute. At 21:40:31, the captain called for the landing checklist. The first officer answered, "Speed brakes armed, gear down 3 green, flaps 30. The speed brakes were not armed. The investigation found the speed brake handle was never moved to the armed position. The checklist item was called. The action was not done. Nobody caught it because the call-out and the check had collapsed into the same thing. The response was given from memory rather than from looking. On a dry runway this would be a footnote. Armed. Speed brakes deploy the instant the wheels spin up. Unarmed. They wait for the throttles to move into reverse. The investigation calculated the delay at about 3 seconds. Then, over the next 53 seconds, the speed went the wrong way. The indicated airspeed climbed steadily from 153 knots to 170. The ground speed went from 166 to 180. The NTSB performance study found both increased at the same rate, which means this was not wind. It was pitch. The airplane was being flown faster. At 21:41:09, at 680 feet, the aircraft deviated further above the glide path. The approach lights would show for white for the entire remainder of the approach. It was also off to the side. For most of the approach, the airplane sat about 100 feet right of the extended centerline. At 1 mile out, it rolled 12 degrees right and drifted to 220 feet right of centerline, then corrected back. And then the airplane started warning them. 6 enhanced ground proximity warning system sync rate alerts were recorded on the cockpit voice recorder, beginning at 21:41:35 and ending at 21:41:42. 6. In 7 seconds. The descent rate peaked at 1,580 feet per minute. The aircraft crossed the runway threshold at 120 feet above the runway, at 170 knots, 17 above target, with a descent rate of 1,450 feet per minute. Miami Air's own stabilized approach criteria say the descent rate should not exceed 1,000 feet per minute below 1,000 feet above the field. By the operator's own written standard, this approach should have been abandoned. The captain stated afterwards that he never thought to call for a go-around. Touchdown. The airplane touched down at 21:41:43, 1,580 feet past the displaced threshold. The manufacturer's target touchdown point is 1,000 feet, with a tolerance of -250 to +500. They landed 580 feet beyond the far edge of that tolerance, at 164 knots indicated and 180 knots over the ground. In the last seconds before touchdown, the tailwind had increased to 12 or 13 knots. For seconds after touchdown, the speed brakes deployed. Reverse thrust was commanded on the number 2 engine, the only one that had it. The auto brakes engaged, then disengaged 1 second later when the captain pressed the pedals, which is exactly how the system is designed to work. And nothing happened. The captain stated in interviews that he applied brake pressure and the airplane did not decelerate. He noticed no anti-skid activation. He pressed the reverse thrust lever hard enough that it left a mark on his fingers. Why the brakes did nothing? The NTSB's probable cause names it directly. An extreme loss of braking friction due to heavy rain and the water depth on the ungrooved runway, resulting in viscous hydroplaning. Viscous hydroplaning is not the same thing most people picture. It does not need a deep puddle. A thin film of water on a smooth surface is enough. The tire cannot displace the last layer of water fast enough, so it rides on it. The wheel keeps turning. The anti-skid system sees a rotating wheel and concludes everything is fine. There is simply no friction underneath. The word that does the work in that sentence is ungrooved. Grooves cut across a runway give water somewhere to go. Runway 10 did not have them. Runway 10 also had a displaced threshold 997 feet in, which left 8,006 feet of landing distance available. Now the part that changes the whole story. Everything described so far, the speed, the high approach, the late touchdown, the unarmed speed brakes, sounds like a crew that lost an airplane. The investigation ran the numbers, and that is not what happened. The NTSB calculated the landing again, assuming the crew had done everything right. On speed, in the touchdown zone, speed brakes armed. The airplane still would not have stopped on the runway. There was standing water on portions of that runway at depths close to the definition of flooded. The maximum braking friction the aircraft actually achieved was far below the figure that every wet runway landing distance in the manual, in the onboard performance tool, and in the industry models is built on. The runway was not wet. The manual's numbers were for wet. The runway was closer to flooded, and nobody had told anyone that. The same calculation run the other way is just as sharp. Had the aircraft achieved the good braking action published for a wet runway, it would have stopped on the pavement, even with the excess approach speed, even with a 10-knot tailwind, even with the delayed speed brakes. So the crew's errors did not cause this accident. They set how hard it ended. The airplane struck the seawall faster because of them. It left the runway because of the water. And the aircraft was working with one thrust reverser instead of 2 legal, dispatched correctly, and on a dry runway completely unremarkable. The airplane crossed the end of the runway at 21:42:10, 8,006 feet past the threshold, 55 feet right of centerline. It struck the seawall 9 seconds later, 9,170 feet past the threshold and 1,164 feet beyond the end of the runway. It came to rest in shallow water in the St. Johns River. The captain called for an evacuation, getting 143 people out. All 4 flight attendants were in their jump seats. The 2 at the front felt the airplane drift right, then heavy movement left and right again, then 2 impacts. The cabin went dark. There was no communication from the flight deck. The captain came out of the cockpit and told them to open the doors and evacuate. And then the escape equipment started failing. The forward left door was opened. Its slide inflated and twisted. The flight attendant could not detach it from the aircraft. She moved to the forward right door. That slide inflated and then began to deflate. She tried to launch a life raft from the forward right door instead. It also deflated. The other forward flight attendant was physically holding passengers back while this happened. Both forward exits were now unusable. In the dark, in a cabin standing in a river. The two flight attendants at the rear had worked out that the aircraft was in water. They blocked both rear exits, told passengers to put on life vests, and moved them forward toward the overwing exits. By the time they got there, passengers had already opened the overwing exits themselves, and some were standing on the wing. 2 more life rafts were pulled from a ceiling compartment in the middle of the cabin. Those inflated. They were deployed off the trailing edges of both wings, and people were loaded onto them from the wing. 143 people came off that airplane through 2 overwing exits and 2 rafts that worked, after 3 pieces of equipment that were supposed to work did not. 1 minor injury. The aircraft that landed 33 minutes earlier, at 21:08, a Navy P-8, which is a military Boeing 737, landed on runway 28 at the same airfield. Its crew stated afterwards that they observed no degradation in braking action. Air traffic control did not give that crew a braking action report before they landed, and air traffic control did not ask them for one afterwards. So 33 minutes before Flight 293 touched down, a 737-sized aircraft landed on that field and formed a first-hand opinion about the surface. That opinion was never collected and never passed on. It would not necessarily have helped. The P-8 landed on the other runway, 33 minutes earlier, and the rain over that field was building the whole time. But it is the clearest illustration in the report of information that existed and never moved. There is one more observation in the file. Another Miami air crew was sitting on the ramp waiting to fly passengers to Norfolk. They described the conditions at the moment Flight 293 landed as, quote, blinding rain. They said the accident aircraft only became visible to them just before it touched down. The question nobody asked. Both pilots stated that none of the air traffic control communications included a runway condition report or a braking action report, and the cockpit voice recorder confirms that neither pilot asked for one. This is the part of the report that is easiest to read past and hardest to forget. For roughly 20 minutes, 2 pilots and 3 controllers discussed which runway had less rain on it. Nobody at any point discussed how much water was sitting on the surface they were about to land on. The captain stated afterwards that, as far as he knew, the runway was not contaminated. He was not being careless. He had no information saying otherwise, and he did not ask for any. What the investigation concluded. The probable cause lists the hydroplaning first. Then it lists what contributed. The operator's inadequate guidance for evaluating runway braking conditions and for conducting en route landing distance assessments. The captain's planned continuation bias, and his increased workload from the weather and from performing check airman duties. And the first officer's lack of experience. The rule that already existed. The operator's own guidance said a crew did not have to redo the landing calculation in flight if 3 things were true. Reported braking action good or better, maximum manual braking planned, and a tailwind of 5 knots or less. Not one of those 3 was true on this flight. There was no braking action report at all, none given, none requested. The crew had briefed auto brakes, not maximum manual braking. And the last wind they were given, 240 at 10 knots, meant a tailwind on runway 10. By the operator's own rule, they were required to recalculate. They did not. And here is the uncomfortable finish to that thread. The investigation concluded that had they run the calculation, they would still have decided the runway was long enough, because in the absence of any braking report, the only reasonable assumption available to them was good braking action on a wet runway. The correct procedure, performed correctly, would have produced the wrong answer. There was a document that addressed exactly this. Safety alert for operators 15009 was already in circulation at the time of the accident. It told operators to assume braking action of medium or fair when computing arrival landing performance on wet runways. rather than good. Miami Air's standard operating procedures did not include that guidance. Had they done so, the crew would have been obliged to assume a surface worse than good, and the arithmetic would have come out differently. Plan continuation bias is worth naming properly, because it is the single most common human factor in approach and landing accidents. It is the tendency to continue an original plan even as the conditions that justified it disappear. It is not stupidity and it is not recklessness. It is what a competent, busy person does when each individual deviation looks small. 100 feet right of centerline is small. For white lights is a correction. 17 knots fast is recoverable. 6 sync rate alerts in 7 seconds is a lot of noise in a cockpit that is already loud with rain. No single one of those is a reason to go around. All of them together are what this accident left behind. The central recommendation is about information. The NTSB pushed on runway condition assessment and reporting, the chain that turns a wet runway into a number a crew can actually use, delivered to them before they commit to the approach. That framework already existed. It is called runway condition assessment and reporting, and it produces a code the tower can pass to an aircraft. This accident was about the gap between having such a system and it reaching the 2 people who needed it at 21:40 on a rainy Friday night. The second thread is the en route landing distance assessment, the calculation a crew is supposed to redo in flight, using the actual conditions at the destination rather than the numbers from dispatch. The report found the operator's guidance for doing this was inadequate. And the third is grooved runways. A grooved surface does not eliminate hydroplaning, but it changes the water depth at which it starts. Here is what makes this accident worth 25 minutes of your time rather than a paragraph. Nothing broke. The engines worked. The brakes worked. The anti-skid worked. The deferred reverser was deferred legally. Both pilots were qualified. The controllers did their job and offered a runway change when the weather moved. And 143 people ended up in a river. Every layer held, and the accident happened in the space between the layers, in the runway condition report that was never requested, in the landing distance that was never recalculated, in the go-around that was never called because each deviation on its own was survivable. The reason everyone walked away is that a Boeing 737 is built to leave a runway at 120 miles an hour and hold together, and the crew evacuated it immediately. That is not luck. That is 40 years of accidents like the 5 you have just watched, turned into structure and procedure. Every figure in this video comes from official investigation records, the Spanish, Japanese, Indian, French and American reports on the 5 accidents in the first half, and NTSB Accident Report 2019050-4X04947 for the second. All of them are public and all of them are linked in the description. If there is an investigation you want us to read next, leave it in the comments.